episode of
Basic Cal! I'm Arvex
And I'm Sheila
from 11 Einstein and currently studying at Rizal National Science
High School. Oh, Arbex, what's our new lesson for today?
I think our lesson for today is all about higher order derivatives.
Oh, that's good!
So guys, are you ready to learn?
Come on, let's go!
Do you have difficulties in solving mathematical equations? Well, this is for you.
We will help you to learn and understand more in solving derivatives, specifically in higher order derivatives. And for our last objectives, we have
In the previous video, we already learned about derivatives and how to differentiate a function. So now, we will proceed to the higher order derivatives of a function. Before anything else, let's first define derivative. The derivative is the rate of change of function at a specified point. On the other hand, the derivatives other than the first derivative are called the higher order derivatives. Let's start our discussion with this function 4x cubed minus 2x squared plus 13x minus 3. By this point, we can get the derivative of this without any problems. f of x is equal to 4x cubed minus 2x squared plus 13x minus 3. In this function, we will use the power rule in finding derivative, in which the exponent of the variable is being multiplied by its constant, and the power is subtracted by 1. So 4 times 3, x raised to 3 minus 1, minus 2 times 2, x raised to 2 minus 1, plus 13 times 1, x raised to 1 minus 1, minus 0. Since 3 is a constant, and according to the constant rule, every constant is always equal to 0. So 3 becomes 0. So 12x squared minus 4x raised to 1 plus 13x raised to 0 minus 0. So f prime of x is equal to 12x cubed minus 4x plus 13. Now, this is a function that can be differentiated. F prime of x is equal to 12x squared minus 4x plus 13. In this function, we will also use power rule and constant rule. So, 12 times 2, x raised to 2 minus 1, minus 4 times 1, x raised to 1 minus 1, plus 0. So, 24x minus 4x raised to 0 is equal to 24x minus 4. This is called the second derivative, and f prime of x is now called the first derivative. Again, this is a function, so we can still get its derivative. F prime of x is equal to 24x minus 4. Again, we will use the power rule and constant rule. 24 times 1, x raised to 1 minus 1 minus 0. So the answer is 24x raised to 0, simplified to 24. This will be called the third derivative. Continuing, we can differentiate it again, and this is called the fourth derivative. Prime of x is equal to 0. This process can continue, but we can notice that we will get 0 for all derivatives after this point. This set of derivatives lead us to the following fact about differentiation of polynomials. Together, the second, third, fourth derivatives are called higher order derivatives. Let's take a look at some examples of higher order derivatives. Example number 1. Find the first derivative, second derivative, and third derivative of f of x equal to 6x cubed plus 4x squared plus 3x plus 1. So, 6x cubed plus 4x squared plus 3x plus 1. We will notice that it is also a polynomial, so we will apply power rule and constant rule. 6 times 3, x raised to 3 minus 1, plus 4 times 2, x squared minus 1, plus 3 times 1, x raised to 1 minus 1, plus 0. So, we will get 18x squared plus 8x raised to 1 plus 3x raised to 0. we will get the first derivative, which is 18x squared plus 8x plus 3. Continuing, 18x squared plus 8x plus 3. 18 times 2, x squared minus 1 plus 8 times 1 plus x raised to 1 minus 1 plus 0. So 36x raised to 1 plus 8. So we can get the second derivative, which is 36x plus 8. In finding the third derivative, 36x plus 8, 36 times 1, x raised to 1 minus 1 plus 0. You can get 36x raised to 0 and simplified into 36. Thus, the answer is 10x squared plus 8x plus 3 as the first derivative, 36x plus 8 as the second derivative, and 36 as third derivative. Let's go to example number 2. Find the second derivative if y is equal to square root of x. Since y equal to square root of x is equal to x raised to 1 half, we can get 1 times 1 half x raised to 1 minus 1 half. So the answer now is y prime is equal to 1 half x raised to negative 1 half. And to find the second derivative, 1 half x raised to negative 1 half, 1 half times negative 1 half x raised to negative 1 half minus 1, we can get negative 1/4 x raised to negative 3 halves. And our answer now is negative 1/4 x raised to negative 3 halves, since we are only finding for the second derivative of the function. Through this lesson, we learned that every function is differentiable. Once we get its derivative, we shouldn't stop because it is just the first derivative. There's still second, third, fourth, and nth derivatives, which are called the higher order derivatives. Moreover, the differentiation of polynomials leads us in getting 0, and adding 1 to the highest exponent indicates the nth derivative in where we can get 0. And if you think that finding derivatives are difficult, don't stop until you get it. Like in reality, we shouldn't lose hope when we encountered some problems. We should continue our lives and solve it, because in every mathematical problems, there's always a solution. Let's continue our lives and never stop finding solution in every problem.
And that's it.
We hope you learned something and enjoy the lesson for today. Till next time!
Bye-bye!